A confusing part in most chemistry classes is the electron configuration. In this video, we hope to give you a few tips that will help you when you're stuck and when you just want to get started. So our question today states that we have to write out the electron configuration in orbital diagram of the element Si, or silicon. So first off, when you're dealing with electron configuration or orbital diagram problems, either one, you should be familiar with the diagram that we have right here and how to draw it, because this will help you with the order and it will help you later on in the problem. Now this order is very important. They do not just go S, P, D, F, or 1, 2, 3. There's a specific order and each order has a specific reason. So before we even get started, let's start off with explaining this order or this pattern in this diagram. So the first thing you do is you list the 1 through 7 S's, one below each other. Then we move on to the P's. And it is important to note that the P's start at 2P, and this is because P has a sublevel that starts at the second principal energy level. And then we now just go down to 7 with them as well. You start the D's at the third principal energy level, and you only need to go down to 6. It's not that the 7 doesn't exist. However, we don't have any elements on the periodic table in order for us to need a 7. And the same thing with the 4. You start at 4 since it is the fourth principal energy level, and you only need to go down to 5. So in reality, we only need a couple of those. Now you take an arrow, as we did right here, and you just sort of try and go diagonally through the diagram. So you start with 1s, then you go to 2s, then you go to 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. That was a long one. And finally, 5f, 6d, and 7p. By doing this, we have just covered the whole periodic table. So as you're filling in the next energy level, you just follow the arrows and you go to where they end and where the new arrow begins. So now that we have our diagram down, let's move on to the actual problem. So an important thing to know when you're doing this problem is how many electrons the element has. So since we're working with silicon, all we do is we go to the periodic table and we check. Silicon, you'll notice on the periodic table, falls 1 directly below carbon. So you'll see when we're doing this problem, the similarities between silicon and carbon. It is just 1 period more. So if we do look on the periodic table, silicon has 14 electrons, so we just start filling up the electrons from there. So we start off with 1s, and the squared there means that it holds 2 electrons. The exponent does not have any mathematical value. So again, it only means that there are 2 electrons in that orbital, as we can see on our diagram. Beautifully drawn, by the way. And then we move on to 2s. And so as you can see, now there's a total of 4 electrons. And now we move on to 2p, which can hold up to 6 electrons. So now that gives us 10 in total. Then we move on to the 3s, which holds 2, and so now we have 12 in total. And now we move on to the 3p, which also holds 2. And it only needs to hold 2 because now in total in our whole equation right here we have 14 electrons. So now we'll start with the orbital diagram. So as you can see, we have a couple of boxes below here. Now, if you were doing the problem on paper, you'd want to write these boxes right underneath the actual numbers in the configuration. But For this video's sake, I enlarged the boxes that way we can clearly see what is going on. So as you can see, each S only has one box, while each P has a total of 3 boxes. And so you just come in and start plugging in the electrons until you get the total number of electrons of the element. So in this case, since it's silicon, we plugged in 14 electrons. So we come into our box and we draw one electron going up and one electron going down. For each of the S's and for each of the P's, as you can see in our final result, you want to draw the ones going up first, and then the ones going down. It's sort of like on the bus how you don't want to sit next to people unless you have to. So you want to try and get rid of all your excess electrons before you start pointing them downwards on the P. And if we count these, you'll see that there's 2, 4, 6, 8, 10, 12, 13, and 14. 14 electrons.